Find the partial fraction decomposition. First thing you want to do is check the degree of the numerator. In other words, the degree of the polynomial in the numerator here is 1. And you got to check the degree of the denominator. The degree of the polynomial in the denominator is 2. So that's a good sign. The degree of the numerator is actually less than the degree of the denominator. Or you could say that we don't have to do long division, and we're ready to break this up into the sum of two fractions. First thing you want to do is actually instinctively factor. See if there's any greatest common factors in the numerator or in the denominator. The numerator stays the same, negative 3x minus 16. They have nothing in common, but the bottom is going to change. There's a GCF of an x, and then what's left is an x minus 4. So notice down here we have something called two linear factors. X is a linear factor because the exponent is 1. X minus 4 is also a linear factor because the highest exponent is once again 1 for this polynomial. The polynomial is x minus 4. So both of these are called linear factors. This one has multiplicity of 1, and the x minus 4 has multiplicity of 1 as well. Now off to the side here, we're going to do most of our work off to the side just to keep things neat. So how do we break up a fraction that has linear factors in the denominator? And the way we do that is simply set this equal to a constant over the first linear factor plus another constant over the second linear factor. Now our goal is to solve for a and b. If we get a and b, then we have actually decomposed the original fraction. Let's multiply the entire sides by the LCD, or the lowest common denominator. Or you could say the least common multiple of the denominators. That will also suffice as accurate language. So what's on the left side now? We simply get negative 3x minus 16. And on the right side we get, let's say, an a. And then we have an x minus 4 left. And then we also have a b. And what do we have left? We just have an x. Now, what we could do is test this equation with very, very specific x values. So I'm going to call this equation triple star. And we're going to test very, very specific x values. Let's test x equals 0 first. If we test x equals 0, then we get this new equation. This new equation says negative 16, right? I mean, if you go negative 3 times 0, I'll write it out for this just to slow things down, is equal to what? A times what here? 0 minus 4 plus b times 0. Well, that's going to yield an equation. In fact, it yields a very, very nice equation. It says negative 16 is now equal to negative 4a. So what does that imply? That implies that a must be what? 4. So we got one of the letters. Now the goal is to get the other letter, b. So what specific test value are you going to pick? And you're going to test x equals 4 in triple star. Okay? So you're testing x equals 4 in triple star. The previous step, you're testing x equals 0 in triple star. If you test x equals 4 in triple star, what do you get now? You get negative 28 is now equal to 0 plus what? 4b. So what does b have to be? B must be negative 7. Now you go back to your expression. What are you trying to do? You're trying to break up your original fraction. Your original fraction now is broken up into 4 over x plus a negative 7 over x minus 4. And if you want to make this look a little bit nicer, you can even say 4 over x minus 7 over x minus 4. So you've broken up the original fraction, one big fraction, into what? Into the sum of two smaller fractions. And so that's why we call this a partial fraction decomposition. I'm going to put a period here. Notice there's a wall here. This wall is very important because in this problem there are two different procedures. Off to the side here, you're working with equations. And then if you look over to your left, which is your main work, you're really just changing an expression. This expression is now changed to look like this expression. So on the left side here is a procedure about expressions. On the right side over here, this is a procedure about equations. Very, very different things going on. So make sure you're able to sort out your procedures between expressions and then equations. Go ahead, excuse me, I'll go ahead and circle my final answer.